morning. We have seen in our earlier classes that for objects moving with non-relativistic velocities, Galilean transformation equations are sufficient to relate the coordinates in different frames of reference, different inertial. When you come to relativistic bodies, that is bodies moving with very high velocity, comparable to that of light, then Galilean transformation doesn't serve the purpose. We have to depend upon new set of transformation equations known as the Lorentz transformation equations. So we are going to derive the Lorentz transformation equations for position and time coordinates in this class. So as usual, let us consider two frames of reference, the S frame, okay, and the S dash frame, which is moving in the positive x direction with the velocity u with respect to the S frame. Mark the axis. So let us mark the origin of the S dash frame as O dash, S frame as O. Now suppose there is a particle or a body moving. Okay, let P be a particle or body which is moving. So what will be the position, let us relate the position coordinates and the time coordinates as observed by these two observers in these two frames of reference. So when a body moves with a constant velocity, you know that in all the inertial frames of reference it moves with the same constant velocity. That is, the laws of physics remain same in all inertial frames of reference. So we know that x will be a linear function of time. Position will be a linear function of time as the velocity is remaining constant. So if the body moves with a constant velocity, the position should be a linear function of time. So in both reference frames, since the laws of physics are same in all inertial frames of reference, we can say that a free body, which is on which no force is acting, will move with a constant velocity in whichever frame of reference you observe. Okay, so you can say that x should be a linear function of time coordinate t. Similarly, x dash as measured by an observer in S dash frame should be a linear function of time t dash. Okay, so the two coordinates x comma t and x dash comma t dash must be related using some linear transformation. So let us assume that the linear transformation is x dash is equal to a1x plus b1t and t dash is equal to a2x plus b2t. So let me summarize. So since the body is moving with a constant velocity, okay, since laws of physics are valid in all inertial frames of reference, the velocity of the body will be constant when you, velocity of the free body will be constant when you measure from both S frame and S dash frame to an observer in S frame and S dash frame. That means that the position of the body should be a linear function of time as measured from both the frames. So x should be a linear function of t. Similarly, x dash should be a linear function of t dash. That means the transformation between these two set of coordinates should be a linear transformation. So let us assume that x dash is equal to t, that is a1x plus b1t, and t dash is equal to a2x plus b2t. Okay, now our aim is to evaluate these constants a1, b1, a2, b2 to get the exact transformation equations. For that, we consider certain special cases. Okay, so let us consider the first special case So let us assume that this particle or this body is at the origin of the S dash frame, that is, it is at O dash. So what will be the position as measured by an observer in the S dash frame? We can say that X dash is equal to 0, right? X dash is equal to 0. Now, how about the position measured by the observer in the S frame? You know that since this body is, this S dash frame is moving with a velocity u, at time t, the position can be written as x is equal to u into t. The position can be written as x is equal to u into t as measured by an observer in the S frame. Okay, so let us substitute this in this expression, equation 1. Let us substitute it in equation 1. Then what do we get? We get 0 is equal to a1 into ut plus b1t, or you get a1 into ut is equal to minus b1t, or b1 is equal to minus a1 into u. Okay, let us take it as equation 3. So in that case you can write x dash is equal to a1x minus a1u into t. So let it be there. Now let us consider the second special case, that is special case 2. Special case 2. Let us consider that this object is at the origin of the S frame. So with respect to S dash frame, you can say that this is moving with a velocity in the negative x direction with a velocity u. Okay, so with respect to S dash frame, you can observe the S dash frame. He feels that this object is moving with the velocity u in the negative x direction. So after time t dash, what is the position measured by the observer in the S dash frame? You can write x dash is equal to minus ut dash, as well as x will be equal to 0 because the object is assumed at the origin of this S frame. Okay, so what does this equation become? You can write minus ut dash, equation 1 becomes minus ut dash is equal to b1 into t. Okay, now substitute this value in this equation also. Equation 2 becomes t dash is equal to, instead of x put 0, b2t. So substituting for t dash here, what do you get? Minus u into b2t is equal to b1t, or b2 is equal to minus b1 by u. Okay, so from these two equations, from here you can write a1 is equal to minus b1 by u. So comparing equations 4 and equation 5, you can write a1 is equal to b2. a1 will be equal to b2. Okay, now let us get back to the transformation equations. Okay, I have drawn the figure now. So linear transformation equations for x dash and t dash is x dash is equal to a1x plus b1t, t dash is equal to a2x plus b2t. We have already obtained the values of these constants, b1 as minus a1u and b2 as equal to a1. Let me write this, b2 is equal to a1. Okay, now let us substitute these equations or values of b1 and b2 in these equations, so that we can eliminate two constants from this. So you can write x dash is equal to a1x plus instead of b1 you can substitute as minus a1u. So minus a1ut. So I can put it as a1 into x minus ut. Okay, x dash is equal to a1 minus a1 into x minus ut. What about t dash? T dash will be equal to, okay, a2x plus instead of b1, sorry, instead of b2 I can put it as a1. So this will be plus a1t. Now let me give this equations number 5 and 6. Okay. Now let it be there. Let us consider the third special case. Special case 3. Okay. Suppose the object P is a light beam. So what will be the positions measured by the observers in S frame and X dash frame? You know that in whichever frame you measure, the velocity of light will be always a constant equal to c as given by the special theory of relativity. So at time t, the position of the light beam as measured by observer O or in the S frame will be x is equal to ct, and as measured by O dash or observer in the S dash frame will be x dash is equal to ct dash, right? So let me square both these equations. I can write x square is equal to c square t square. This equation on squaring we get x dash square is equal to c square t dash square. So rewriting this equation, I can write it as x square minus c square t square is equal to 0, as well as x dash square minus c square t dash square is equal to 0. So we can equate these two. Okay, I can put x square minus c square t square is equal to x dash square minus c square t dash square. Now let me substitute these equations in terms of x and t. Let's substitute for x dash and t dash in terms of x and t. So what do I get? Instead of x dash square, you can put it as a1 into x minus ut. So squaring, I get a1 square into x minus ut whole square. Okay, minus c square into t dash square. So c square into a2x plus a1t whole square. Right? So let me rub off this. Now our next step is to expand these brackets and equate the coefficients of x square, t square, etc. So this becomes a1 square into x square plus u square t square minus 2xut minus c square into, squaring this, what do you get? a2 square x square plus a1 square t square plus 2a1 a2 xt, right? 2a1 a2 xt. So x square minus c square t square gives this. Now let me group the x square terms, t square terms and xt terms. Okay, so taking the x square terms, I can write x square into, in the first bracket you have a1 square, from here you have minus a2 square c square. Okay, now let me combine the t square terms. Here you have a1 square u square, and here you have minus c square a1 square. So plus t square into a1 square u square minus c square a1 square, and last the xt terms. So I can put it as xt into, you have 2xt both sides, 2xt into minus a1 square into u minus a1 square into u. Okay, here it is minus c square into a1 a2, minus c square into a1 a2, right? Now equate the coefficients of all these terms on both sides. So what is the coefficient of x square? On the left hand side it is 1. On the right hand side it is a1 square minus a2c square. So equating the coefficients of x square, t square and xt, you can write coefficient of x square is 1 on left side, on right side is a1 square minus a2c square. Okay. Now what about the coefficient of t square? On left hand side it is minus c square, right hand side it is a2 square, right hand side is a1u square minus c square a1 square. And what about 2 xt term? Here left hand side it is 0, right hand side it is minus 2 into a1 square u plus c square a1 a2. So solving these equations, you can obtain the values of a1 and a2. These are the equations which we have obtained while equating the coefficients of x square, t square and xt. So let me number them as 7, 8 and 9. I am choosing this equation, equation 8, to get a1, the value of a1. So let me rewrite it. C minus c square is equal to a1 square into u square minus c square. So what is a1 square? That is equal to minus c square by u square minus c square, or I can put it as c square by c square minus u square by multiplying by minus 1 on the numerator and denominator. Or I can write it as a1 square is equal to dividing by c square on the numerator and denominator. I can put it as 1 by 1 minus u square by c square. Or what is the value of a1? It is 1 by root 1 minus u square by c square. Okay, so we have obtained the value of a1. Now let us obtain a2 so that the transformation equation is complete. Okay, so let me choose the equation 9 because on the left hand side is 0 and it will be more easier to simplify. So from equation 9 I can write a1 square u plus c square into a1 a2 is equal to 0. So you can substitute for a1 and obtain a2, or divide throughout by a1. So you get a1u plus c square a2 is equal to 0, or a2 is equal to minus a1u by c square minus a1u by c square. So a1 is 1 by root 1 minus u square by c square. So you can write this is equal to minus u by c square by root 1 minus v square by c square. Okay, now let us get back to the transformation equations. So what will be the transformation equations finally? You can write x dash is equal to x minus ut by root 1 minus u square by c square. Substituting for a1, you get it as x minus ut by root 1 minus u square by c square. And what about t dash? T dash will be equal to a1t plus a2x, right? So a1 is t by root of 1 minus u square by c square. What is a2? It is minus u by c square root of 1 minus u square by c square. So you get it as minus u by c square into x by root of 1 minus u square by c square. So substituting for a2, you get it as minus ux by c square by root 1 minus v square by c square. So the u square by c square. It's not v, it's u. So the final expression is t minus ux by c square by root of 1 minus u square by c square. Okay, so this is the transformation equation for time. So since the motion is along the x-axis, the motion of the dash frame is along the x-axis, we haven't considered the y-coordinate and z-coordinate because they remain same as in the case of the linear transformation equations. So the final set of transformation equations will be x dash is equal to x minus ut by root 1 minus u square by c square. You can add the other transformation equations. Y dash is equal to y, z dash is equal to z. They remain the same as the motion is along the x direction. And the transformation equation for time coordinate is t dash is equal to t minus ux by c square by root of 1 minus u square by c square. And as a homework, you can find out the inverse transformation equations. Just write down the equation for x in terms of x dash. Okay. So obtain the equations for x and t in terms of x dash and t dash. Those equations will be known as the inverse transformation equations.